Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Tami. We are from Group K, and today we are going to present our assignment project, which is object detection. Without further ado, let's begin. So, our group had developed the object detection for fruits by implementing the CNN, or convolutional neural network deep learning. We use Fruits 360 for our dataset, especially the folder named Fruits 360 100 times 100, which contains image of fruit resized to 100 times 100 pixels, which means that each file has 100 width pixels and 100 height pixel. So, what is our objectives for our assignment project? So, firstly, we want to implement a deep learning model that can detect and classify the types of fruits image accurately. Secondly, we want to evaluate object detection for performance for accuracy so that the model can upgrade, which means we can update the model to detect the type of fruits accurately. So next is the platform we use for the coding. So we use the Google Colab to implement convolutional neural network deep learning using Python coding. We choose Google Colab because it is free and is friendly for all the users. Also, it provides the cloud GPU for user to run the code faster, especially in during the training the models. So that is the benefits of Google Colab. This is the website named Kaggle. We use Kaggle to import dataset, which is Fruits 360. But in this case, we only use the folder named Fruits 360 100 times 100 for our dataset. So that's all. And for the introduction, next, our friends will explain the coding in Google Colab.
Assalamualaikum warahmatullahi wabarakatuh. In this video, I will walk you through our code that we use to build the deep learning model for object detection. We'll be using the Fruits 360 dataset to identify and classify different types of fruit. So first, of course, we need to import all the standard libraries such as NumPy to handle numerical data, and also Matplotlib and Seaborn to visualize data, and also TensorFlow. TensorFlow is the main library we'll be using to build and train the neural network. The TensorFlow Keras provide tool for the CNN. And also we have to import the image data generator and other layers such as conv 2D, max pooling 2D, and dropout, which will allow us to design the architecture of the model, pre-process images, and prevent overfitting during training. Okay, so now we use Kaggle Hub to download the Fruits 360 dataset from Kaggle. The dataset contains images of 201 different types of fruits, which is perfect for our object detection tasks. So now we load the images from the directories using TensorFlow image dataset from directory function. The function will automatically scan the folders and assign labels based on the folder name. So if the folder name is Apple, it will automatically label Apple. If the folder is banana, it will label banana. And we specify the image size to be 100 by 100 pixels to ensure all images are the same size, which is required for input into the neural network. The dataset will be divided into training and test sets. The training will be used to teach the model, while the test dataset will allow us to evaluate the model's performance on unseen data. Okay, we also set the label mode to categorical, which means that the labels will be one hot encoded. For example, if there are 201 fruit types, apple might be represented as 1000, etc. Okay. So after we have loaded the data, we need to do data augmentation. Data augmentation is a technique to artificially increase the size of the dataset by applying random transformation to the image. This helps the model to generalize better and avoid overfitting. Overfitting is when the model just memorizes the image and it performs well on the training set, but it performs worse on the actual test set. So to avoid overfitting, we use the data augmentation. We use TensorFlow sequential model to define our data augmentation. We use three types of augmentation: random flip to flip the image horizontally, random rotation to rotate the image by a small random angle up to 10%, and also random zoom to zoom on the image by up to 10%. So this transformation will be applied randomly during training to create slight variations, making the model more robust. So now, the most important part of our code, which is the CNN, or convolutional neural network, the model itself. We're building CNN, which is a type of neural network that's very effective for image processing tasks. So first, we need to rescale the images. Image pixel values are from 0 to 255. We need to scale them to be between 0 and 1. This normalization helps the model learn faster and more effectively. And then we apply data augmentation to introduce variability in the training images. Okay, so next, we define the convolutional layers. These layers will scan the images and look for features such as edges, corners, and shape. So the first convolutional layer uses 32 filters to detect simple features such as edges. Second and third layer uses 64 and also 128 filters, which enable the network to detect more complex features. So after the convolutional layer, we need to flatten the output to turn the 2D feature maps into 1D array, which can be passed into fully connected layers. Okay, and then after that, we add fully connected layer or dense layer with 128 neurons to help the model combine the features that we have trained them from the previous layers. We also use a dropout layer with a rate of 50%. This means that during training, the model will randomly ignore half of the neurons to prevent overfitting. So finally, the model ends with output layer. The output layer has 201 neurons for 201 types of fruit, and we use softmax activation. Softmax ensure that the output represent probability, which means that our model will give probability for each fruit class, and we choose the class with highest probability. So once the model is defined, we compile it using the Adam optimizer. The Adam optimizer helps the model learn by adjusting the weights during training. It adapts the learning rate based on the gradient of loss function to speed the training process. We also use categorical cross entropy as the loss function because we are performing multi-class classification, and the goal is to assign one label to each image. Finally, we try accuracy to see how accurate the model in predicting the fruit class. So now it's time to train the model. We use the fit function where we pass the training dataset and specify the number of epochs. One epoch is one full pass through the entire training dataset. We set it to 20 epochs, which means that the model will see each image 20 times during training. We also pass validation data, which is the test dataset, to evaluate how well the model is performing after each epoch. This gives us feedback about how well the model is generalizing to unseen data. The fit function will output training progress, including loss and accuracy. So once the training is complete, we evaluate the model on the test set using the evaluate function. This gives us the final loss and accuracy of the model on the test data. High accuracy means the model is performing well. Low accuracy means the model is not performing well. To visualize the model performance, we plot the training and validation accuracy and loss over each epoch. As you can see from the graph, the more we train the model, the more epochs the model has gone through, the higher the accuracy. The same goes, the more the epoch, the lower the loss. And also, if you can see from the validation graph, it is high from the start, which means that the model responds well to the training. So finally, we test by passing a batch of images. If you can see here, our model accurately predicted all the images. Okay, so if you can see that all of the images here are apples. Why apples? We actually have other fruits as well, but because apple is too much, there are so many apples in our dataset, it randomly gives out apple. So as you see, the model accurately predicts all of the fruits. So I think that's all for the code. That's all from me. Assalamualaikum warahmatullahi wabarakatuh.
Okay. Assalamualaikum. My name is Muhammad Aiman bin Abdul Razak, number matric 2312215. Okay. I will present about my part, which is a conclusion. In this project, we successfully built a fruit classification system by using a CNN that trained by using a 360 fruit dataset. From this project, it highlights how deep learning can play a big role in automating tasks in agriculture. Our model uses a multi-layer CNN architecture with techniques like dropout and data augmentation, which helps us achieve a better and solid accuracy. During this project, we have faced some limitation, which is mainly limitation in computational power, and the fact that our model only classified unit and classifies fruit without detecting their exact location in the image. Okay, moving forward, for the future work on this project should incorporate bounding box regression using YOLO or SSD, and use transfer learning with models that have already been trained. Implementation of collision handling strategies such as mosaic augmentation optimize the system for real deployment on edge device in agriculture team. setting, and also using ResNet MobileNet for more efficiency. Some key lesson we took away include how crucial the augmentation is for helping model generalize well, and how powerful CNN can be for image-related tasks. We also learned the importance of tracking validation performance closely to avoid overfitting. As for our team, Adam worked on processing the data, while Basha developed the CNN, and I focusing in tuning hypermeter and creating visualization. Okay, that's all from me. Thank you.